Hello everyone, my name is Max, and in this video I'm going to show you how to solve the question about oxygen levels in the ocean and in the air. And this question was about the partition coefficient. So we're talking here about an equilibrium state between oxygen in the air and oxygen in the water. And for water was already given to you, which was 8 milligrams per liter. Well, since this is equilibrium, we can write 0 is Ca minus m times C water. Note that I could also write the m before the a, but then I wouldn't find a partition coefficient larger than 1, which was given in the exercise. So what we want to do is find the value of the partition coefficient. So I can rewrite this equation to the concentration in the air over the concentration in the water. And we're talking about the oxygen levels here. And since this one was already given to you, I only have to calculate the concentration of oxygen in the air, which was 20% of everything, all the molecules in the air. So I write 0.2 times the density, because the density is actually also some kind of a concentration, but then from all the components. And I know that density is mass over volume is the number of molecules times the molecular mass is equal to the mass and still over volume. So do you recognize here something? Yes, we do. For this part, actually also is included in the ideal gas law, which is this equation. And here I have my NMV. And since we're talking about a gas here, we can use this ideal gas law. So let's use it. And if I then rewrite this equation, I can find the concentration of oxygen in air is 0.2 times the molecular weight. And then I fill in N over V. And that is actually the same as the pressure over the gas constant times the temperature. And I can fill in the numbers, find the answer to the first question, which is done 1.18 kilograms per square meter. And then I have everything to find my partition coefficient. I know my concentration in the air and my concentration in the water. And I find 29.5. So that's that for question 1. Question 2 was about the fish living in the water, and they would die if oxygen levels would be getting too low. So now we're going to see what happens if we change the pressure and what happens then to the oxygen level in the water. But what happens to the partition coefficient? Well, actually, this one stays equal. It stays the same. It's just a fact what happens between water and air. So we cannot do anything about it. So what then? When do they not survive? Well, that was given, and it was when the oxygen level in water goes below 2 milligrams per liter. So what we know is that the concentration in air for oxygen is the partition coefficient times the concentration in water. And the concentration in water is known, the partition coefficient is known, so also the concentration in the air is known. That corresponds to this 2 milligrams per liter of air in water. And again, we can use the ideal gas law. The pressure is R times T over M. which I have also used down here. And I know that again, the amount of oxygen is just 0.2. But now I'm rewriting this equation, right? It's the same. And if I fill this in, I can find the final equation, which we can just fill in to find the correct answer, which is 0.25 bar. All right, and then the last part was to do an analysis how the concentration of oxygen in the water changes with increasing pressures or decreasing pressures and changes in temperature. And here the pressure was given in blue, the temperature in red in the exercise, so I'll do it here the same. And also we had a concentration of water here. So what we know is how the concentration in the water is defined. It's like this. And we can rewrite it again to this form. It's the same as last exercise, but now we write it for the concentration of water. And if we evaluate this equation, we see a pressure over here, and we see a temperature over there. So what we do see now is that when the pressure rises, the concentration in the water rises linearly with pressure. So this is a straight upgoing line. And also the concentration in the water of oxygen is going down with 1 over the temperature. And 1 over the temperature gives you a negative reciprocal, which looks like this. So this was the correct graph you had to choose. I hope that you have understood how this exercise works. If not, please ask us any question on the forum. See you in the next video.